In this video, we are going to look at differentiating x to the power of n. However, the integer or the power of n is a negative integer. So in these examples, we'll cover these examples here. And we'll start off with the first one. So in all of these questions here, it's asking us to differentiate with respect to the corresponding variable. So in this particular question, it's asking us to differentiate y with respect to x. In this particular case here, we want to have the ideal form for us to differentiate is when the power is negative in the numerator. So our step here is to straight away differentiate, and we differentiate this by taking the power, multiplying it at the front, then subtract the power by 1. Now, what we can do next is we can re-express this as a positive index or power by taking the x to the power of -3, making it jump the line into the denominator. For question B, we already have all of our powers here as negative expressions with negative powers. This one here is just a constant, so we can jump straight into differentiating as well. Take the power, multiply it at the front, subtract the power by 1. Same with the second term. And the third term here is a constant, so therefore it will be +0, so it disappears. What I'm going to do is take an extra step here and bring the negative powers down into the denominators. Now don't hesitate to play this faster if you feel like you're on track, or if you want to go ahead, or you can always skip forward as well. In this particular question here, our x to the power of 4 is in the denominator. So we want to make sure we bring everything up into the numerator first before we differentiate. So in this next line, I'm going to rewrite y, which means that I am not differentiating just yet. Now I'm going to find the derivative, because the equation of y is in an ideal format. So we take the power, multiply it at the front, we get -12, and we subtract the power by 1. Okay, since we have a negative power, we're just going to bring that back down into the denominator. The reason why I like writing the indices as a positive expression is because if we ever need to substitute, then it's much easier to evaluate this term if we have a number inside where the x is. So far we've got dy dx. But next we have d. So we are differentiating d with respect to z or z. So perhaps I'll write that down. Differentiate d with respect to z. Now again, before we differentiate, we need to rewrite these terms with negative indices. So I'm making the z's at the bottom or the denominator to jump the line and bring them into the numerator. Once we've derivative. Once we've done that, then we can find dd dz. Take the power, multiply it at the front, and subtract the power by 1. Just going to zoom a bit. -5 times -3 becomes positive 15. You take the power, multiply it at the front. Oops. And this constant here becomes +0, so we don't need to write anything there. Last step, we're just going to bring down those negative powers back down into the denominator. It's 4 examples down. So perhaps if you don't have a booklet, maybe pause the screen here so that you can see the questions and you can give them a crack. Give them a try yourself. But I will continue here. These are already in negative powers, so we're going to jump straight to finding the derivative, dy dx. Take the power, multiply it at the front, and subtract the power by 1. Take the power, multiply it at the front, that becomes a +1, and you subtract the power by 1. This is a constant, it becomes +0, so the constant disappears when you differentiate. This is just a little study tip here, and you can take it as you will. But when you are considering, when you are learning, or when you're doing this as an exercise, take into consideration about saying things out loud. And practice reading out loud. Because this will help you process, but it will also help you memorize as well, particularly with equations. Now you can see here in this particular example, we do have an x squared in the denominator. What I'm doing is I'm splitting up this fraction, so I'm splitting up these two terms in the numerator, and they will both be divided by x squared. I'm going to simplify this. So notice we have not differentiated yet. It's still f of x, exactly the same. So we've got 5x plus 1 over x squared, 1 over x. And to make it in a acceptable form for differentiation, I'm going to bring this denominator to the numerator. Now this is in an acceptable form, we can find the derivative. And the derivative will be f dash x. So we're going to differentiate 5x, that becomes 5. Take the power, multiply it at the front, becomes -x, and then you subtract the power by 1. I'm going to re-express this here as 1 over x to the power of 2. Very similar skill here. We're not going to differentiate just yet. I'm going to break up all the terms and divide by n to the power of 3. And I'm going to simplify. So 2n squared plus 3 over n minus 6 over n to the power 3. Then to make it so I can differentiate it, bring all the n's in the denominator into the numerator. Once that's done, you can find the derivative. And in this case here, because it's in function notation, we can write p dash of n. So we're going to take the power, multiply it at the front, and subtract the power by 1. Once that's done, last but not least, we're going to rewrite all of the terms with positive powers. And you're done. There's one more example here in this negative powers video. This here is the operator notation. So it's not an equation. There's no equal sign here at the front. In fact, this is an expression, okay? So when we do this, in the line underneath, we're evaluating. So we can just put an equal sign directly there. And we take the power, multiply it at the front, and subtract the power by 1. This is a constant. So when you differentiate, it becomes plus 0, or disappears. Last step, rewrite as positive indices. So there are all the examples that we've done in this video. Don't forget to pause the video, rewind, and rewatch if you would like to revise. Thanks for watching.